All right. All right, we're going to go and move on from binder check now. So if you're still working, you can circle back to it in the last 5 minutes. Here's the plan. We're going to derive equation 2. Then we're going to take a break, do a brain break, and then look at your reading quiz from yesterday. Then we'll go back and do equation 3. All right, so a little bit of algebra today. I promise it'll be okay though. All right, let's do 2. Step 1. Let's copy our acceleration equation kind of like we did before. Acceleration is delta v over t. And then I'm also going to copy this equation. Now this is one we've not actually worked with before, but this is the average velocity equation. So I'm going to copy both of those just side by side. So I've got acceleration on one side, equation 1, average velocity on the second one. And what I mean by that is this is the distance traveled by an object, and there's 2 different velocities. That's why we have velocity final plus initial over 2 times some unknown time t. So if I take this equation, let's rearrange it in terms of time. So we would have t equals delta v over a. And the reason I'm doing that is because if you look at our final equation, the thing we're working toward up here, what is lacking in that equation? There's no time. So we need to get rid of time. The way we do that is through substitution. So let's substitute equation 1 into equation 2. In other words, this right here, t, we're going to plug in here. Okay, so if we did that, I'll write it next to this plus. We would have d equals v sub f plus v sub o all over 2. And then instead of time, actually I'm going to write that in the corner. Let's see this all over. Hold on, sorry. I write it first this way. We would have v sub f plus v sub o over 2. And then in place of t, I'm plugging in delta v over a. Sorry about that. Now, if I'm combining these 2, in other words, if I'm multiplying left by right, this would be, let's combine some like terms. So step 4, out of d equals how would I combine these 2? What would it look like? Let's do our numerator. So yeah, but like, how could I rewrite delta v? Maybe that will help us. Anytime we do a change in something, it's final minus initial. Thank you. So we can do v final minus v initial over here. And then this first one is v final plus v initial. All over 2a. So I can be in the quadratic formula song. All over 2a.
Hey, which ones?
Or is it 4a? No, it's 2a. Right? Sorry, it's been a while. I've slept since.
Isn't that the extension of initial over initial?
Kind of. Now, if we notice, we can multiply both sides by 2a. So step 5. Let's do 2ad equals. Now, if I want to simplify this top part, the numerator, how do I solve or combine this into some kind of usable form? Foiled it. Yeah. Somebody said it. I got a foil. Front, so we're going to have df squared. Outside, we're going to have minus v sub f, v sub o. Now, don't let these subscripts trip you up. Just think of them as like labels. Then in the middle, I'm going to have positive VO times VF, so that's going to be positive v sub f, v sub o. And then minus v sub o squared. And the nice thing about writing it like this is, what do you notice about those middle 2 terms?
They cancel out.
They cancel. Yeah, I have a negative one and a positive one. Think of it as like negative xy plus xy. That just it cancels, it goes away. leaving me finally with our final form of our equation, number 6. I'm going to add v sub o across, so I'm going to have vf squared equals v sub o squared plus 2ab. Now, if I lost you right there, we added v sub o squared across, add v sub o squared across, and then I just rewrote it so that my right side was my left side was right side, just so that it would match this formula up here. Stephen.
No. Can I skip 5?
Sure. Now, this, you can put a box around. This is our final formula. And as you'll mention, when is a good time to use this formula?
When we're trying to find out the final velocity without the usage of time.
Right, when we don't have time. If you don't have time, boom, you should automatically go to this formula. Now, a couple notes about our formula chart. We call this equation 2 because it's the second one we're deriving, but in reality, on our formula chart, this is actually equation number 3. So of our big 3, remember in the top left that we looked at of our formula chart, 1, 2, 3, this is actually the 3rd one. So be careful on that. The other thing about the formula chart, I'm going to put it here. The way they write this equation is a little different. They put v sub x squared equals v sub x sub o squared plus 2a x minus x sub o. So if you want to, if you want to put that next to it, this is the formula chart version. This is kind of the way we'll do it, easy mode to start. If you notice, they've changed displacement to x minus x sub o. Those are the same thing. You can even, how could you also write it? Instead of this, you could write delta x, yeah. Or if you put delta v, that would be displacement too. There's like 9 different ways to describe the same thing. There's many ways to skin a squirrel. So these are functionally the same equation. All right, let's do an equation. We're going to do one practice together, then we're going to let you try one. All right, Mr. Bronco. He gets on the highway in his 1967 Shelby 427 Cobra, traveling at 11 meters per second. That's on the Christmas list, by the way. To his right, he sees his nemesis, Mr. Trask, in his red 1998 Honda Civic, and he guns it. After 145 meters, he's traveling at 32 meters per second, so he's flying. We don't know what's the Cobra's acceleration. Now, some of us already know the acceleration of a 1967 Shelby 427 Cobra, but for the rest of us, let's solve it.
Is that your favorite car machine or something?
It is not, but it's up there. It's up there.
You like Subaru Forester.
The Subi, can't go wrong with Scooby.
Scooby Gang.
The Scooby Gang. Scooby the Subi. Okay, sorry. Plus,
That's the name.
2AB, that is the name of
Wait, what is it?
Scooby the Subi. It's got a rhyme, yeah. I used to have a Jeep, a little Jeep Liberty, and her name was Bo Peep. Bo Peep the Jeep. Then I got Scooby the Subi. Okay, let's go through this and kind of think together. And we're going to show our work, set good habits. What am I solving for in this problem?
Acceleration, Cobra's acceleration.
Boom, I'm going to underline acceleration. I want to know, what is A? So step 1, get everything else that's not A on the other side of the formula. So VF squared minus V sub O squared all over 2D equals A. And it's good to do this symbolically before you start plugging in your numbers, before you start thinking about what have they given me, what have they not given me. Just do it symbolically. Then it becomes easy to plug in our numbers. What's my final speed?
Yeah.
That's this 32. 32 meters per second is VF, and all of that is squared, minus
11.
11 is my starting speed. All of that squared. All over 2 times my displacement, 145. 145. Now, before you plug this into a calculator, please excuse my dear Aunt Sally. If you do not follow your order of operations, you're going to really screw this up in the calculator. Okay? I want you to try it, though, and tell me what number you get. Let's see if you know how to order of operations. Your calculator is only as smart as you are. Remind it who its master is. Good. I got the same answer. Can you get an answer? Shout it out.
It would be cool if you had a scuba on your Subi, so that it'd be scuba.
The scuba on the Subi with the Scooby? Oh my gosh. Wow.
Then you could like drive it.
That's true. I'll add that to my Christmas list. I need to
How long
find a
is the
trailer.
cover?
Trailer is right. Yeah, with the cover. Ooh, you can get the Scooby on the cover.
On the trailer.
On the trailer, on the Scooby.
What does car look like?
All right, what are we getting for an answer? Should be like single digit between 1 and 10? 3.11. Let's say you didn't get that because you don't calculate it. Here's what you should have entered into your calculator. First, you do. Hold on, I gotta get this on camera. I know y'all can't see this, but I'm gonna say it out loud. 32 squared minus 11 squared.
Oh, it's a square.
Enter. Divide by, open parentheses, 2 times 145, close parentheses, enter. Then you'll get 3.11. I know it's kind of backwards for y'all, but you can see the order of operations. If you don't put that parentheses around your denominator, what's it going to do? It's going to do 32 squared minus 11 squared, then divide by 2, then multiply by 145. Dear Aunt Sally, don't forget about it. So 3.11. Now, at the end of any of these acceleration questions, it's usually good to kind of check yourself. Is this a reasonable we don't really have a way to answer that yet, but what's a reasonable acceleration? Small. Small? That's a good answer. Are you familiar with gravity? Experience that at all? So like 9.8 meters per second squared, that's 1 g of acceleration. So like witness gravity. Wow. So that was an acceleration of 10 meters per second squared. We're saying this car, giant, massive moving metal, is accelerating at 3, a third of a g. That's reasonable. If it would have gone like 300, that would tell me that as I accelerate, I would be pulling 10 Gs, okay, like an astronaut taking off to space. So this is a reasonable value. Later on, we'll work in terms of Gs, and we'll see if things make sense. We'll do a question with a roller coaster as we go through a loop. Gs. Right. Gs Louise. Let's let you try one. An engineer is designing a runway to accommodate planes that gain a ground speed of 360 kilometers per hour before they take off. These planes are capable of being accelerated uniformly at a rate of 2.78 meters per second squared. How many kilometers long must the runway be? That works. Yep, 3.11. Hint, what do we need to do with the units? Oh, we got to convert them. You're still struggling with that? Start with something like this. Convert 1 hour up here, 3,600 seconds. 1 kilometer down here, 1,000 meters. That's going to give you a speed in meters per second. Then you can start your formula. All right, start talking and comparing answers, or start talking and saying where you're stuck. See if you can help each other at this point. About 30 more seconds to talk to each other. Yeah, here's some good numbers. If you felt good about it, Julie, what did you want to do?
We all got different jobs.
That's okay. Give me some examples. Okay, right. So if we go to our original question, we want to know how many kilometers. So let's kind of work through and see if their numbers match up to what we're thinking. We know that this velocity is 0. Right? We start at 0. Our final speed, they tell us, has to be this, which is 100 meters per second. When you multiply the top, multiply the bottom, and divide. So I have 100 meters per second squared equals 2, well, I guess we'll just divide across. 2 times my acceleration, 2.78. This answer should be about 1,799, but that's not the answer.
1.7.
The answer is 1.79 kilometers.
So I'm saying convert it.
So this is a multiple choice question. Here's what I would do, because I'm evil. I would put as an answer on a multiple choice test, I would put this answer, and I would put kilometers, and I would put 1.79 kilometers, and I'd probably put 0.179 kilometers, and then I'd put like 8 or some other random number. But as soon as you get an answer, check your units. This is meters squared per second squared over meters per second squared. So that's going to leave me with just a single meters. No. Since it asks specifically for kilometers, I would at least be that consistent. Now, this does bring up a good point, though. We'll look at the bottom. This is the last thing, then we'll talk reading quiz for a minute, take a short brain break. What system do we need to use? It says this should be completed using the blank units. Yeah, the international system is what it's referring to, which you can also know as the metric system, but it's truly the system international. The system international. You can say it in French and it sounds really fancy. I can't say it in French because I don't know French besides for omelette du fromage, but I mean cheese omelet. What are some examples of those units? What's the unit for distance?
Meters.
Meters. So meters. What about time?
Seconds.
Seconds. We at least get that right in America. We use seconds. We do the whole New York second thing, which is kind of weird. But what about mass? So we use grams, but kilograms is really going to be like our go-to. Kilograms is kg. That's good. And then what about temperature?
Kilograms.
Good. Kelvin. Not Celsius. Kelvin is actually the absolute scale.
Absolutely.
Right? Absolutely. If you don't know why,
That's STP right there.
ask a chemist.
Wait. Yeah, it is.
STP. 0 Kelvin is true absolute 0.
But what's standard temperature or pressure? I forgot. Is it 0 Celsius or is it 0 Kelvin?
0 Kelvin. No. I think it's 0 Celsius.
Yeah.
That's a lot. And we can just put et cetera. Because like obviously there's others like liters, there's coulombs,
Yeah. Safety might be-
lumens. We don't deal with line. I think it's physics too. Yeah, optics is 2. Yeah, she can sense the disturbance there. All right, let's take a break. Here's your brain break today. Did we do we're doing Guns N' Roses in here before?
Yeah.
Okay.
John's. good
This
at
is
it.
like next level Guns N' Roses. Okay, I'm gonna turn the light on. 3, 2, 1. Okay. You're gonna draw with your fingers 1 circle clockwise. The other one you're going to do counterclockwise. Okay, but at the same time, so it's gonna look like this. Don't do this. This is not it. 2 opposite circles. See if you can do it. Try it. You can stand up. It'll help you. Stand up, and try it.
Cool for you, Mr.
John is just like next level.
Mr. Henderson.
Oh gosh, they're in. Hello, dog.
Hello.
Are you in a car? What are you on a bus?
And we're in a car.
Great. We're just taking a brain break, so you're here at perfect time. We're trying to draw circles like this.
Yeah, we've been here for like 5 minutes.
Perfect. Opposites are not.
Hey, Calvin.
Calvin?
Yeah, it's easy. And I looked at my grade.
Here you go. Calvin said hi. Calvin's buying me a Shelby Cobra for Christmas. So
I thought there's a Model Y for $15.
Okay, Mr. Henderson.
folks, you got 30 seconds to finish up, wrap it up, sit down. Bell, you have 30 seconds.
We're not gonna stay on here the whole time, but we're gonna go in and out of service. But I wanted to say hi.
Okay, good to see y'all. I'm recording, so we'll have the rest for y'all.
Okay.
Henderson.
Emma said hi too.
All right. Hi, Emma. Yeah, they're on the bus.
All right, bye.
What is
That is
that?
very interesting. I'll have to try that.
You should get it ready. So let's do this. And then do a triangle.
And then you do them
And then do
simultaneously.
No, can't do that one. I'll have to get a video on that.
It was amazing.
No, that's literally what I learned in quarantine. I did that for like an hour. I could do it.
All right, let's talk reading
I was, like,
quiz.
struggling, and then I just kind of did it like without even thinking about it. It's just if you think about it, you mess up.
Interesting. I'll have to play with that later. Here is the score distribution. So overall, it wasn't bad. Now, the average was about 8, which is really, really good, honestly. And we'll talk about the frequently missed questions. So that was mainly number 10, John. Number 10 is right here. It says figure Q 2.16 shows the position graph of a car traveling on a straight road. The velocity at instant 1 is blank, and the velocity at instant 2 is blank. If you don't remember what that graph looked like, jump to question 10. This is the graph. Now, how do I find the velocity at each of these points? Slope. So what's the slope at 1? Negative. What's the slope at 2? Still negative. It's a little less negative, that's true, but it's not 0. What's the position at moment 2? That's 0. That's 0. So many people fell for that trick. So don't fall for that next time. The other one was this, number 8. 8 talked about an elevator moving downward. So if I'm moving downward, I should be thinking in my mind, okay, the velocity must be negative. So by thinking just that much thought, A is out, C is out, because that has a positive velocity. Positive velocity. Negative velocities, it's got to be B, because that's going towards 0. If I'm slowing down, I need to be approaching 0. So that's why some people got picked D, got it wrong. It's okay. Don't miss it next time. All right, let's go back to notes and finish up. Overall, I was impressed. I think you guys really dug into it. All right, we're going to derive the equation and be done so. So last bit of algebra. Now, you'll notice at the top, it says finally from the equations, blah, 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 blah. What do you notice about this first equation? This is the first kinematic formula. So now we're going to use kinematic formula 1 with the average velocity one that we just used and make a baby out of those two so that we can get equation number 3. Star, star, star. This is the difficult one. Okay, so let's do it. Let's rewrite 1 just for the sake of writing. VF equals VO plus AT. Okay, 2, if you want to rewrite 2 here, just to say you can. D equals VF plus VO over 2 times T. And just like before, I'm going to substitute 1 into 2. But this time,
Is that an A or a B?
Here.
No.
here, that's a B. Make them taller. This time, I'm going to plug it in for VF. So notice right here, I can plug in this VO plus AT. So in place of VF, I'm going to plug in this full term. Okay, so let's rewrite. Step 3. This is where we start substituting. D equals. Instead of VF, I'm writing VO plus AT. So that's VF, VO plus AT. Now plus VO is still hanging out up here, the original one from the formula. All over 2 times T. I know, looks kind of nasty. Let's clean it up. Step 4. We're going to do 2 steps here. Okay, let's distribute T inside and combine the two VOs. Are we okay with that? So I would have D equals VO plus VO is gonna give me what?
2 VO.
2 VO. These, think of V sub O as just like an X. It's just a variable. So 2 V sub O times T, again, if I'm distributing this T inside, plus, now AT times T is AT squared. All over 2. Okay, I know that was a bit complex. We did a few steps there. Tell me this, math police. Can I just like cancel this 2 out?
No, because it's not all of them.
Right, we have to also consider our guy AT.
Variable.
If there was a 2 over here, we could, but since there's not, we still have to consider it. So let's do this. Let's rewrite this, step 5. As D equals, displacement is equal to, divide this by 2, so 2 VOT over 2 is just D sub OT, plus this AT squared is going to become 1/2 AT squared. That's the same as just keeping AT squared on top and keeping a 2 in the denominator.
Oh, I remember this
Does this
one.
make sense? So your 1/2 AT squared equation, boom, we're done. This is your last kinematic formula, which on the formula chart is actually equation 2. But we save it for last because 1, it has a weird fraction, and 2, time is squared, and it's in this first term. So there's going to be times when we use this one, and we're going to have to do quadratic formula. We're going to have to factor. But there's equations for that. There's things in your calculator that you can make it work for you. Now, like we've done, I want to mention the formula chart version, just kind of side by side again. So on the formula chart, they write this as very strange. They write x equals x sub O plus v sub x sub O T plus 1/2 a sub x t squared. So what have they done here? Why have they written it
I
like this?
separated the VO.
So my VO, we've labeled it with an X. And then instead of writing D for displacement, they've actually written the X and the X sub O on separate sides of my formula. So this way, this gives me my net displacement. This way, this would only give me what? This is my final position. Yeah. So that is one difference between how we do it on the formula chart versus where it's kind of derived here. But functionally, they're the same. Now, because some of you are math nerds and you'll appreciate this, I just want to mention, what's up with the 1/2 here? Like obviously, algebraically, we've shown why there's a 1/2. But can anyone think in terms of the velocity versus time graph of why there would be a 1/2? This is for my like next level people. Sorry, I thought I turned go. Okay, let me help you a little. If we're showing an object that's accelerating, right, these are all acceleration equations, what would the velocity time graph look like for an accelerating object? I'm seeing diagonals drawn in midair. Okay. If I'm looking at this equation, or this formula rather, I'm thinking about displacement, what do I look at on the graph?
Under
Area. What's the area here? Triangle. How do you find the area of a triangle?
1/2 distance times the height.
1/2 base times height.
Whatever.
So that's why the area here corresponds to a displacement, which is why we have this 1/2 here. It has to do with the fact that the area under the curve is a triangle. So it's kind of cool. It's neat. Doesn't really matter. It doesn't affect us, but it's cool. Okay, we're not going to do the practice because we've done enough math for one day. Now, that's good news because you have 10 minutes. What should you do in that 10 minutes?
Procedure sake.
Yes. Get back, talk procedure, think about your lab. If you need to run things by me, you can. If you didn't get to look at ramps yesterday, you can. If you need to hop into the meets and talk to your people, you've got 10 minutes. Let's do it.